This is a question from the half-yearly exams for the general class, the HSC general class. It was attempted by a few students, but I just want to point out to some of the things they did not understand and could not solve. If we look at the question, if Moivers Manufacturing Company produces cans of magic beans, the can has a diameter of 10 centimeters, which is quite obvious on the diagram, and the height of 10 centimeters, which is there too. Now, cans are packed in boxes that are rectangular prisms with dimensions of 30, 40, and 60 centimeters. Now, some students might miss the word dimensions, but they've been taught that dimensions is the height, length, and width, or could be the depth. So if we're looking at rectangular prism, so if we're looking at this rectangular prism and putting the information there, we could put the 60 on the side, which I mean the front, and we could have taken that as 40 and the height as 30. Thinking of that, now looking at the first question, what is the maximum number of cans that can be packed into one of these boxes? I'm just going to put the dimensions again on this box. So if we say this is about 60, 40, and 30. Now some students calculated the volume. We're asking how many cans you're going to place. So we are missing what's in between the cans. We're not considering to add the space that's wasted between the cans. So if I can say I can pack around 4 cans on this side, and I can top up with 3 more levels because each one is 10. So, and the height is 10. So I can put 10 on it, 3 of them on top of each other, and I can put 4 on this side. And then you can find the bottom, how many you can place on the first level, which is 4 times 6, which gives you 24. And then you know that's the lower level, and you're topping it by 3 levels, so you're going to multiply that by 3, and that gives you 72 cans. This is the maximum you can pack into this box. So there was no need to find the volume of the can of the box, and it was worth 1 mark only. 1 mark for this. Now looking at the second part, which says the shaded label on the can wraps all the way around the can with no overlap. So it's not overlapping, and it wraps all the way. But we have to consider when we look at the picture, back to the diagram, the can, even though the height is from there to there 10 centimeters, there is a little bit is missing up the top, 0.5, and from the can at the bottom there is 0.5. So the label, it only covers from there to there all around the can. So it's missing a 1.5 centimeter. Therefore, the height that we're going to use for the wrap should be 9 centimeter, and some students missed that point. Okay, so finding the actual surface area. Again, the surface area is given to them for the cylinder, but they need to consider that they're only taking the curved surface area, so they're not considering to calculate the 2 circles. Therefore, if they look at the surface area back from the formula sheet, which says 2 pi r squared plus 2 pi r h, this is going to be cancelled because the wrap does not go over the circles. Therefore, the surface area or the shaded label on the can should cover only 2 times pi times the radius. That's another thing. They were given in this case the diameter, which is 10 centimeters. So students had to realize and be careful to divide that by 2, which gives you 5 centimeters. So these two, some of them missed it. So we have a 9 times 5. Using the calculator, that will give you 282.74, and the unit is centimeters squared because we're calculating surface area. And this is a label for 1 can. Okay, some of them did that, but it says in the question, the shaded label on the can wrap all the way. What area of paper is needed to make the labels for all the cans? So they missed the point of multiplying this number, surface area, by 72, because this is for 1 can. So that's another mistake. So multiplying this by 72, and that will give you an answer of 20,357.28 square centimeters, and that's the total paper that they need. And the question was asked to find the area of the paper that they need to label all the cans. So looking back at the question, part 2, they needed to know the height, to take the half a centimeter from the bottom, half a centimeter from the top. They needed to watch out for they were given the diameter and they had to make the radius half the diameter. Then another thing, they needed to cancel the actual 2 circles. And a fourth point, they needed to multiply their answer by 72. So it's quite tricky, but it was worth 2 marks. Now in part 3, the company is considering producing larger cans. So larger cans. Monica says if you double the diameter of the can, this will double the volume. Is she correct or not? Justify your answer. This is where you need to find the volume. This is where you have to find the volume and use the volume formula. So the formula is given to them, pi r squared h, and they are considering doubling the diameter. The diameter for the first one was 10, so we're going to consider having the diameter 20. The radius, that means in this case 5, the radius in this case is 10. So they need to find the volume in both cases. So volume for the first one would be pi times 5 squared times 10, and that will give you 785 and 40.40 cubic centimeter. For the second one, you would end up with a pi times 10 squared times 10, and that will end up with 3,141.59 cubic centimeter. And if you look at it, this number is not double the number volume 1, so therefore she is not correct. This is all they had to do. So they needed to find the volume in both cases, and that's worth 2 marks as well.